Simultaneous equations. If you think back to my last video, we looked at the case where you had a system of two linear equations. So this consisted of the first equation, which had an x variable and a y variable, and the second equation which also had an x variable and a y variable. So a system of two equations and two unknowns. And this is always going to be the case at A level. You'll never look at a situation where you say have three equations with three unknowns, although you could actually solve that system of equations and obtain a numerical variable for each of those letters. Today, rather than looking at two linear equations, we're going to be looking at one linear equation and one quadratic equation. But broadly speaking, your steps are going to be exactly the same. And this is the case of whether you're looking at two linear equations, one linear equation and one quadratic equation, which is what we're going to do today, or the case where you have one cubic equation and one quadratic equation. So if you think back to my last video, steps are up there on the board, and I'll just whiz you through the example we looked at last time very quickly. So steps. Number one, make one variable the subject of its equation. So you're rearranging either of the two equations such that one of the variables is the subject of that equation, i.e. you have either x or y by itself on one side of the equation. Step number two, you're going to substitute that rearranged equation into the other equation, and then you're going to solve for one of the variables. So after this step, you will have either x equals a number or y equals a number, and then from that you've obtained one of your x values. So you've obtained one of the values in that coordinate pair, so it might be the x or it might be the y, and you're going to substitute that value back into one of your original equations to obtain the other variable. So let's take a look at the example we looked at previously. So look at these. These are my fantastic notes. Go on my website, purchase them. Best few pounds you would ever have spent. So situation we had last time was this. Okay, two equations. First equation, here you can see 3x plus 5y equals 8. Second equation, 6x plus 2y equals 4. It is two equations, equation 1, equation 2. Each has two letters in each, so two equations and two unknowns. Step one, we chose this first equation here and we rearranged it, making x the subject. Just remember here, it doesn't matter whether you choose x to be the subject, it doesn't matter whether you choose y to be the subject, it doesn't matter whether you choose to rearrange equation 1 or equation 2. So this is the rearranged form of our equation here. I just called it equation 3 for the purposes of my notes. And then we substituted this rearranged form of equation 1 into equation 2. So if you notice, you're comparing this with this, I now have, every time I see my x here, I now have this expression for x on the right hand side in this bracket here, and I simply expanded the brackets and solved this. So here, once you substituted in your rearranged equation into the other equation, this will leave you with a linear equation in just one variable, so you can solve for that variable. In this case, it's going to be y. And once I found my y value down here, I just substituted it back into one of my original equations. So I chose this one here, made things nice and easy, and then obtains my final value for x. Okay, so final answer, you need a solution for x, a solution for y. You solve those two equations simultaneously. So if you bear with me, after the jump we will be looking at one example of a system of equations where one is linear and one is quadratic. We're going to go through two examples. So after this break, we're going to look at example 1. After the second break, we're going to look at example 2. After the third break, we're then going to take quite a holistic overview and look at what this means in terms of interpreting the question graphically. Example number 1. So if you take a look here, equation number 1 is clearly my linear equation. Equation number 2 is clearly my quadratic equation because it has that squared power there. Obviously the equation with squared powers in that is going to be your quadratic equation. I think generally speaking it's going to be easier to rearrange the linear equation. So just remember, step 1, you need to rearrange one of the equations such that either x or y is the subject of that equation. So I think, generally speaking, it is easier to rearrange the linear equation. And again, it doesn't matter which of the variables you choose to make the subject of the equation. I'm actually going to make life more difficult for myself here by rearranging this to make x the subject. So you've got y plus 2x equals 2. I want to make x the subject. How do I get x by itself? I need to undo that positive y term on the left hand side. So subtract y from both sides and then divide through by 2. So 2 divided by 2 is 1 minus y over 2, or half y. Okay, so that's step 1. Rearrange one of my equations, making either x or y the subject. Step number 2, I need to substitute in this rearranged form of the equation into my second equation here. Oh, actually, I've made life easier for myself, and I want to make life more difficult for myself. If you want to see an example of me making life more difficult for myself, then wait after the break, and we'll look at another example. Okay, but I'm going to substitute my rearranged form of this equation here into this second equation here. So basically, anytime you see an x, okay, you're going to replace it with this expression for x on the right hand side of this equation here. So here's my x. Okay, I'm going to replace this with 1 minus y over 2. Okay, equal to 8. So this is substituting equation 1, or rearranged form of equation 1, into equation 2. Simply going to expand and solve for my y now. So on my notes, this will probably be labelled as step 3, but in terms of your broader steps, I guess it's still part of step 2. So just expanding this out, 8 times by 1 gives me 8. 8 times by minus y over 2 gives me minus, okay, positive times by a negative, 8y over 2, or just 4y. This is equal to 8. Now, what I'm left with here is a quadratic equation. So just remember, when you're dealing with a system of linear equations, the equation that you formed when you substituted your rearranged form of equation 1 or 2 into the other equation was a linear equation. So you can solve that just in quite straightforward fashion. Okay, the equation that you're left with here when you get to step 2, once you've completed step 2, is going to be a quadratic equation. So rearranging this, just remember what you need to do when you solve quadratic equations. You need to move all of your terms over to one side of the equation, and then generally speaking you're going to factorise, and this is normally the case when you're dealing with a system of equations where one's quadratic and one's linear. You should be able to factorise the resulting quadratic once you've completed step number 2. Okay, so all I'm going to do, move all of my terms over to one side of the equation. How do I do that? All I need to do is move this 8 over to the left hand side. So I'm going to subtract 8 from both sides. What does it leave me with? So this y squared term stays the same, this minus 4y term stays the same. I'd have plus 8, but I need to minus an 8, so that just disappears essentially. Y squared minus 4y equals 0. Okay, solving this, just remember, I give you a broad overview of solving quadratics in another one of my videos, but broadly speaking, there's 3 different methods of factorisation. Number 1, your first port of call when you're thinking about factorising is, can I take out a common factor? In this case, yes, I can. Okay, I can take out a factor of y. What times by y gives me y squared, which is y. What times by y gives me minus 4y, which is minus 4, equals 0. So you notice here we're going to get 2 solutions, so either y equals 0 or y minus 4 equals 0, which means that y equals positive 4. Okay, so notice here we've got two y solutions, which means that we're going to get 2 solutions for our x as well. So we're on to step 3 now. We've found our solutions for one of the variables. We now need to find our solutions for the other variables. How do we do that? Exactly the same as when we're dealing with a system of linear equations where both of them were linear equations. All I'm going to do is substitute in the variables that we've identified, the variables that we've obtained numerical values for in this step here, into one of my original equations. Okay, and I think this one here, this fella here, looks the easiest. So y equals 0 implies that x equals 1 minus 0 over 2, i.e. x equals 1, and then y equals 4. So now we've this step here, we're looking at our first y value. We're figuring out what the x value is going to be when y takes value of 0. Now, second example here, we're looking at what happens when y equals 4. What's our x value going to be? So x is going to equal 1 minus, okay, my y value goes in there, 4 over 2, which equals 1 minus 2 equals minus 1. Okay, so x equals minus 1 there. So you notice, final solution for this one, I've been left with two values of x. So I'm just going to express these as coordinate pairs. So when x equals 1, y equals 0. And when x equals minus 1, y equals 4. And so you notice here, I have two values for x, two values for y. My final answer can be expressed as two coordinate pairs. This isn't always going to be the case, but it will be the case a fair amount of the time. If you wait till the last part of this video, graphically I will interpret what it means to have two solutions like this, one solution, and it's also possible to have no solutions as well. Okay, so wait till after the break. Next we will be taking a look at a probably a more difficult example of a system of a system of equations where one's quadratic and one's linear, but algebraically it's going to be slightly more difficult, and I think it's definitely worthwhile watching this second example. Example number 2 now. So just to illustrate a point, I've got example number 1 written up there on the right. If you're comparing example 2, so we're going to look at this one in this section of the video with example number 1, which we looked at previously. Not too drastically different. But if you're looking at our quadratic equation here in the second example, you notice both of my terms are now squared compared to our quadratic equation here where only one of the terms was squared, and also we have this this coefficient on one of our squared terms. I'm going to make life more difficult for myself, like I said I would in this part of the video. I'm going to substitute in place of my y in step number 2. Okay, and this will make, it's just algebraically, you need to be aware of the order in which you perform certain operations when you encounter this kind of situation. But in terms of my steps, step 1 is exactly the same. So I'm going to choose my linear equation. I'm going to make x or y the subject of this equation. So if you're being smart about this, you'd actually make x the subject here, because then you wouldn't have to deal with this 4 in front of your squared term. But I'm going to make y the subject, so we have 2y equal to 7 minus 2x. Okay, so let's just write this up here for completeness. So 2x plus 2y equals 7. Okay, next step is subtract 2x from both sides. Okay, it leaves me with 2y on the left hand side, 7 minus 2x on the right hand side, and simply dividing 3 by 2 leaves me with 7 over 2 minus x. That's step 1. Now I'm going to put equation 1 into equation 2 now. So some of you might label this equation 3, that's absolutely fine. That's what I've done in my written notes, my typed up notes. Putting equation 1 into equation 2. So basically, anytime I see a y in this equation here, I'm going to replace it with this expression equivalent to y on the right hand side here of my rearranged equation. So what I'm left with is x squared minus 4, my y now, 7 over 2 minus x squared equal to 8. Now the important part here. So you notice I have this thing squared multiplied by 4. I need to expand those brackets to begin with, dealing with the squared term first. So what I'm going to do, write this out in full. So something squared means that thing multiplied by itself. So I've got 7 over 2 minus x multiplied by itself. So I need another 7 over 2 minus x in there, equal to 8. Okay, just expanding those brackets inside the square brackets now. So just dealing with these two sets of brackets, expanding them out, I'm going to have 49 over 4 minus 7 over 2x minus 7 over 2x plus x squared. That's going to be equal to 8, of course. Now, so here we have equations with fractions. So first port of call, you should be looking at this 4, thinking, oh, I need to expand this all out. Here, don't be tempted to multiply through by 4. I know, generally speaking, if you have an equation with a fraction in, your objective is to get rid of that fraction by multiplying through by the denominator of that fraction. So in this case, you might be tempted to multiply through by 4 to begin with. I'm just going to expand those brackets to begin with, because essentially this eliminates the fraction within this set of brackets here. So sorry, let me just tidy these terms up in the middle first. So I got 7 over 2x minus 7 over 2x. That's just the same as minus 7x. Collect those two together, plus x squared, all equal to 8. Now I'm going to expand, so getting rid of that 4, what am I left with? 4 times by 49 over 4. Essentially this one cancels with this one, so leaves me with minus 49. Minus 4 times by minus 7x leaves me with plus 28x. And now minus 4 times by plus x squared leaves me minus 4x squared. Is equal to 8. Now, continuing to work with this, collecting like terms together, I've got x squared minus 4x squared. That's minus 3x squared altogether, plus 28x minus 49 equal to 8. And then just moving that 8 on the right hand side over, subtract 8 from both sides, I'm left with that. So just remember, when we're dealing with a system of two linear equations, when you substituted one equation into the other, you're left with a linear equation, essentially a linear equation that you needed to manipulate and solve. So dealing with any fractions, dealing with any brackets, etc. The same is true when you have a system of equations where one is linear and one is quadratic. But once you get to this step here, once you've substituted in one equation into the other, you're going to be left with essentially what is a quadratic equation that you then need to manipulate. Remember, when you're solving quadratic equation, I do go through this in some detail in one of my other videos, links up there. When you're solving quadratic equations, you need to get everything, you need to get the equation into the form such that you have all of your terms over one side of the equation, i.e. one side of the equation needs to equal 0, and that allows you to factorise. Coming up here now, I'm just going to rearrange this one here. So we have this. I think personally for me, I find it easier factorising quadratics when my coefficient on x is positive. So I'm just going to multiply through both sides here by minus 1. Ooh, forgot my x. Minus 28x plus 57 equal to 0. Now factorising this is quite a tricky looking quadratic to factorise. You're looking at plus 57, you're thinking, well, actually, what numbers go into 57? Yes, I agree with you. It is a difficult one to factorise. Just remember, if you're in this situation where you're solving a quadratic, you can always use the quadratic formula. So if you're spending, I don't know, 3-4 minutes trying to factorise this and it's just not going, then just use your formula. But this one does actually go. Factors of 57, actually 19 and 3 are factors of 57. So if I do this, then it does actually come out to what we need. So if you just think about it, 3x times by x gives me 3x squared. Then I'd have 3x times by minus 3 minus 9x. Minus 19 times by x gives me minus 19x. Minus 19 times by minus 3 gives me plus 57. Okay, so those two do indeed give me minus 28x there. So that is that expression there on the left hand side correctly factorised, equal to 0. Okay, now just solving this, again we're going to have two solutions, so 3x minus 19 equals 0, or x minus 3 equals 0. Look at this one, 3x equals positive 19, x equals 19 over 3. Okay, so just dividing 3 by 3 there, or more straightforward, just x equals 3 here. So we've got our two solutions for x, and then similar to the previous example, moving on to the final step now. Once we've obtained our values for one of the variables, we need to go back into one of our original equations and obtain our values for the other variables. So I'm going to use this one here. Okay, so when x equals 19 over 3, this implies that y equals 7 over 2 minus 19 over 3. Okay, just expressing this as fractions over 6. 3, 21 there, minus 19 over 3. Ooh, 19 over... Sorry. Beg your pardon. Over 6. That'd be 38 over 6, so I'd be left with minus 17 over 6, and obviously that doesn't cancel, so that would be your y solution when x equals 19 over 3, and then you expect this second one to be more straightforward. So when x equals 3, y equals 7 over 2 minus, so I'm just looking at this, substituting 3 into here, 7 over 2 minus 3. Again, just changing this, so 7 over 2 minus 6 over 2, which equals half. Okay, so a more straightforward answer there. It's just expressing this as coordinate pairs. So just remember, if the question asks you to find the coordinates of the points of intersection between these two lines, then you need to express this as coordinate pairs. So your final answer would be here for this one, simply 19 over 3, comma, minus 17 over 6. First coordinate pair, second coordinate pair, 3, comma, half. Okay, so that is a harder type of example here. So key points to remember. Just remember here, you can actually make life easier for yourself by making x the subject of this equation, in which case you don't need to expand this term here by that of 4 that's going to go in front of your brackets. It does make life easier for yourself. But once you get to this stage here, just remember that you need to obtain a quadratic equation here, and then solving your quadratic equation, if you're struggling to factorise what seems to be quite a difficult quadratic, as was the case here, then it's also possible to use the quadratic formula to obtain your values of x or your values of y. You're going to get to exactly the same result. Okay, so lastly, just graphically what we're doing here. So you notice each of the previous two examples that we've gone through in this video, they have resulted in 2 x values and 2 y values, i.e. 2 coordinate pairs. So just quite generally, if I have a quadratic curve, so you know your quadratic curves are either going to be U-shaped or N-shaped, and I have, so this is my quadratic, and I have a linear equation, i.e. the equation of a straight line. You notice when you're solving simultaneous equations, we've already said that essentially what you're doing is finding out the points of intersection between those two functions. So in this case, notice here I have 2 points of intersection, okay, and obviously there's going to be an x and a y coordinate for this one. Call it x1, y1, and also here x2, y2. So 2 coordinate pairs there, 2 values for x, 2 values for y. So that's the situation we've encountered thus far. Two possible solutions. Oh, actually that's a bit better. Okay, alternatively, it's actually possible if my straight line is tangential to this curve, i.e. they only meet at one place, kind of there, it's quite hard to draw on, then you're only going to have one coordinate pair. So once you combine your equations and you solve that resulting quadratic, you're only going to get one answer. Okay, you're going to get one answer, and similar to when you had solving simultaneous linear equations, you're going to have one value for x and one value for y. But it's also possible to not have any solutions at all. Okay, so if this is my quadratic and my straight line looks like that, you can see there are no points of intersection. There are no points where this straight line will intersect with this quadratic curve here. That's obviously not the case with straight lines. If I have, so on the left hand side we have a system of equations where one is quadratic and one is linear. If we have a system of equations where where both of them are linear, okay, unless the two lines are parallel like that, then the two lines will always cross. Okay, there are no situations where I can move this line here such that the two lines won't cross. If you think about it visually, two straight lines, just so long as they're not parallel, they will always cross. There will always be a point of intersection. So to summarise, a system of linear equations, you're always going to have one solution unless the two lines are parallel, whereas quadratic equation combined with a linear equation, so that's what this video has been looking at, you're always going to have either no solutions here, perhaps one solution, so one x value, one y value, or two solutions, so two x values, two y values, i.e. two coordinate pairs. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.